Hi, this is lesson 71 for my Algebra 2 students. Today we're going to be talking about the quadratic formula. Now, I had a couple of you on Zoom the other day, and we discussed this. It was only 2 lessons ahead, and we get to it. So I'm actually going to kind of do 2 lessons in one. Over here, we're going to complete the square to solve for x, and at the same time, I'm going to take this equation here, ax squared plus bx plus c equals 0, and we are going to do this. We're going to complete the square in this one also, and from it we will derive the quadratic formula. Quadratic formula is just a formula that you can take, and rather than factoring or completing the square, you're going to be able to take all these numbers, 3, -2, and 5, and just simply plug them into this formula and spit the answer out. So this video might actually take a little longer than others. My last one was right at 13 minutes. This might be longer. So let's get into this. Here's a quadratic equation, and by the way, this is the same equation as example 71-1. Now I'm not going to do like they do in the book. I'm going to do completing the square with this, and then we'll come back and show what they do in that example. If I told you to complete the square with this, the very first thing you would do would probably be to divide by 3. We're actually going to do 2 steps at once. We're going to divide by 3, and we're going to move this 5 to the right-hand side because it does not have an x with it. So let's show that. Divide by 3, divide by 3, divide by 3, and move this over here where it's -5/3. We could have shown -5/3, -5/3. I'll just do that. Here is an abstract quadratic equation where instead of the number 3, they have the letter a, because it can be any number. This could have been 4, 5, 6, or 7. Could have been any number in front of the x squared. And the b could have been any number in front of the x, and the c could have been any constant. In fact, a, b, and c can all be the same number. We just don't know. Excuse me. Just like over here, I divided by 3. On this quadratic equation, I'm going to divide by a. I moved the positive 5/3 to the right where it became -5/3. I'm going to move the c over a to the right where it becomes -c over a. We're going to do a side-by-side comparison. This on the left will give me x squared minus 2x equals -5/3. We're now ready to start figuring out how to finish this quadratic, how to complete the square. We take the coefficient of x, 2. We either divide it by 2 or we multiply it by 1/2 if it's a fraction. We'll divide this by 2. And we square it. That gives me 1 squared. That gives me 1. We'll come back to this in a second. Over here, let's rewrite this. This is x squared plus b over ax. Don't write it as bx over a. Write it as b over a times x equals -c over a. We're going to take the coefficient of x, and in this over here on the left, because it was just 2, we divided by 2. Because this is a fraction, we're going to multiply by 1/2. Same thing, divided by 2, multiplying by 1/2. This gives me b over 2a, and that is also squared. That gives me b squared over 4a squared. Over here, I normally just go ahead and write +1 there, +1 there, but I want to show it as a different step. +1 equals -5/3 plus 1. We're going to do the same thing here. X squared plus b over ax plus the b squared over 4a squared equals -c over a plus b squared over 4a squared. I'm going to have to write a little bit smaller because we've got a lot more to get in here. I should have not left such big gaps there. This is now a perfect square trinomial, as is this. That doesn't look like something you could factor, does it? But if you've done your work correctly, it naturally is. What does this factor into? This factors into x minus 1 quantity squared. It's 1 because the 1 is the number that got squared. It's minus because this was minus 2x. Equals. I need to add these things together. Negative 5/3 plus 3/3 gives me negative 2/3. This is a perfect square trinomial also. It will factor into x minus something squared. What goes in there? The number that got squared, b over 2a. Is it plus or minus? I look here. It was positive there. It must be positive here. I need a common denominator on the right-hand side. I'm going to multiply this by 4a, both top and bottom. That'll give me 4a squared. I'm going to write the b squared first because it's positive. This gives me b squared minus 4ac and all over 4a squared. I didn't finish this over here. Yes, I did. Negative 2/3. Take the square root of both sides. I get x minus 1 equals plus or minus the square root of negative 2 over the square root of 3. Oops, I didn't write that square root of 3. What did I mess up? I've messed up somewhere. We'll get it in a second. Over here, take the square root, x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over the square root of 4a squared. I'll have to figure out my mistake over here in a second. What did I do wrong? Well, I'm going to have to do this whole video over again. This stinks. Let me look real quick. All right. 5/3, complete the square. 1 plus 1 plus 2. Oh, everybody see my mistake? This was 2/3 all along. This is easily fixed. I'll just erase this. I apologize. I wonder if you guys saw that early on. You couldn't yell out in class and get a piece of candy. 2/3 times 1/2 quantity squared. Just like we had to multiply by 1/2 there. Don't write 2/6 squared. It is 2/6, but the 2's cancel. It's 1/3 squared. And that is 1/9. So I have x squared minus 2/3 x plus 1/9 equals negative 5/3 plus 1/9. Yeah, this is going to work out much better. By the way, that was still a perfect square trinomial. I just copied it from x minus the number that got squared, 1/3 quantity squared, equals multiply by 3, multiply by 3, negative 15/3 plus, 15/9 plus 1/9. That's negative 14/9. Take the square root of both sides. X minus 1/3 equals plus or minus the square root of negative 14 over the square root of 9. Now, we've caught up to where we needed to be. I'm going to move this 1/3 to the other side of the equation by adding 1/3 to both sides. I get 1/3 plus or minus. The square root of negative 14 is the square root of 14 times the square root of negative 1, which is the letter I. And the square root of 9 is 3. There is the answer to that. Over here with the quadratic formula, I move the b over 2a to the other side. Here it's positive. On the other side, it's negative, and we still have a plus or minus the square root. And over, the square root of 4a squared is 2a. You cannot take the square root of this b squared. You cannot take the square root of that 4 either. They are both perfect squares. That minus in the middle messes you up. So we just have to keep it as b squared minus 4ac. I hope you can see that it's kind of sloppy here. But this is the quadratic formula. If we were to have just taken these numbers here in the middle and plugged them into this formula, we would have gotten the same answer. Let me show you where this comes in handy. This is what we did by completing the square. We had all those steps. If we had just said, okay, A equals 3, B equals -2, you got to keep that negative with it, and C equals 5, we can plug them into that formula. X equals the opposite of B, the opposite of -2, which is +2, over 2 times A, that's 2 times 3, plus or minus the square root of B squared, that is -2 squared. Don't forget the parentheses, it's -2 times -2, minus 4 times 3 times C, which is 5. X equals -B plus or minus the square root of B squared minus 4AC all over 2A. Now, here in a moment, we're going to put this all over one denominator. Notice this has a denominator of 3 and a denominator of 3. We could have written the whole thing just over 1, 3. Denominator of 2A, denominator of 2A. We can write them all over just 1, 2A. We'll combine this 2 times 3 and this 2 times 3 in a minute. So this gives me 2 plus or minus the square root of 4 minus 4 times 3 is 12 times 5 is 60 all over 6. Well, that gives me 2 plus or minus the square root of -56 all over 6. We have to break down the square root of 56. 56 I can divide by 2. That gives me 28. I can divide that by 2. That gives me 14. I can divide that by 2. It gives me 7. It doesn't go any further than that. So I get 2 plus or minus the square root of 2 times the square root of 2 times the square root of 2 times the square root of 7 times the square root of -1. There's the negative from that. All over 6. When you when you clean this up, the square root of 2 times the square root of 2 gives you 2. So we have, I'm going to go back up here, 2 plus or minus 2. These two became the 2. The 2 and the 7 can't combine with anything, so they just become 14 again. The square root of -1 becomes I, and it's all over 6. I can take a 2 out of every term. Don't think of the 14. We're not taking a 2 from that. But I can divide this 2 by 2. Give me 1. I can divide that 2 by 2. It gives me 1. I cannot divide the square root of 14 by 2. I'd have to divide by the square root of 2, or something like that. And 6 divided by 2 is 3. There we have it. 1/3, or 1, plus or minus the square root of 14i all over 3. These two say exactly the same thing. We're able to do it by using the quadratic formula. I sang a little song the other day. Here's how you remember the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. We could draw that all under one denominator. Now, you need to know how to do this. This takes 1, 2, 3, 4, 5, 6, 7 steps. Knowing how to derive the quadratic formula is something I've had my students do every year. It's a quiz I give them. They have to show me all 7 steps. They can't just say, oh yeah, you go from here to there. How we're going to do that during this crisis, I don't know. But there's a quadratic formula, and you don't have to complete the square anymore. You can just plug these coefficients in for A, B, and C, and then solve. And that works. Hope that helps. right at 15 minutes. You guys have a good day. We'll see you later.